Good morning and welcome to our Zoom with the HR MacMillan Space Centre. We have Trish and Rachel from the Space Centre here today, and we are going to be talking about asteroids and comets. So you guys can take it away.
Cool. Thanks,
Awesome.
Haley. I'm excited about our topic today, talking about comets and asteroids and kind of what is the difference between the two. So I'm hoping you can help with that.
For sure. Alrighty. Okay, so we're talking about asteroids and comets today. So let's begin with the basics. So what even is an asteroid? Well, an asteroid is just a chunk of rock and metal that's in outer space that happens to orbit or go around the sun. Now, asteroids can have all sorts of shapes and sizes. Some are the size of pebbles, and others are even as big as mountains. Now, they orbit the sun just like planets do, but they're much smaller than planets. So sometimes we call them minor planets. They're also not round like planets are, but instead they're actually kind of bumpy and lumpy, kind of like potatoes. So where did asteroids come from? Well, asteroids are really just the leftover stuff from the formation of our solar system billions of years ago. Now, I talked a little bit about the formation of our solar system last week, but I'll remind you about what we talked about. Now, our solar system began as this swirling cosmic cloud of gas and dust that was flat just like a pancake is. And then in the center of this cloud, our sun formed and it got really hot and ignited. Now, along with our sun, what we know now as planets, comets, and asteroids were also forming. Now, there are a lot of asteroids in our solar system, but most of them live between the orbits of Mars that you see right here and Jupiter. And we call this place where these asteroids live the main asteroid belt. And that's all these little orange dots that you see right here. But asteroids can be found almost anywhere. And Earth even has a few asteroids itself that follow Earth around. And they're called near-Earth asteroids, or NEAs. Now here's a video of a NASA mission called NEOWISE. And it shows the number of near-Earth objects, so things that are close to our Earth, or what we call NEOs, that it has found over the years. Now, each NEO is represented by one of these little tiny dots that you see around in a circle. And now, since the mission was restarted in 2013, so 7 years ago, it has found almost 700 of these near-Earth objects, so 700 of these dots close to our Earth. Now, NEOWISE has discovered brand new asteroids and brand new comets, but it's also provided really good data for many of these objects that were already discovered. Because in science, it's not only important to collect brand new data, but also to collect more data on old objects too. Now, I mentioned that during the formation of our solar system, we had planets and asteroids being made, but we also had comets. So what are comets? Well, comets are really just dirty snowballs, the dirty cosmic snowballs of dust, ice, gas, and rock that also orbit our sun. Now, when a comet's orbit brings it close to the sun, just like you see here in this little GIF, it actually heats up and spews out dust and gases, leaving behind a little tail, or what we call the comet's tail. Now, there are billions of comets in our solar system, but most never really pass by that close to Earth. Now, you might have also heard about meteors, meteorites, and meteoroids, which all kind of sound like the same thing as asteroids and comets. So what's the difference? Well, in space, if you have a big rocky object that orbits or flies around the sun, we call that an asteroid or a minor planet. But if you have something that's a little bit smaller, the size of particles or little points that also orbit the sun, we call those meteoroids. So those are really, really small rocks that orbit the sun, smaller than asteroids are. Now, if you have a meteoroid, the small kind of asteroid that's flying around in space, and it just so happens to end up near Earth, and it actually ends up flying through Earth's atmosphere, it'll start to burn up and become really, really bright. And we call these meteors. Now, you might know them by a different name. Sometimes we call them shooting stars because they burn up really, really bright in our atmosphere, and they look kind of like a shooting star that's streaking across our sky. Now, a meteorite is one of these meteors that ends up surviving through its passage through our Earth's atmosphere. So it burns really bright, but it's still able to end up passing through our atmosphere and landing on Earth's surface. So if it does make it through our atmosphere and lands on the surface, we call that a meteorite. I also put the definitions of asteroids and comets below, just as a reminder what the difference between all these different terms are. Now, what I think is really cool is that we actually landed on a comet way back in 2014. And the Rosetta spacecraft was the one that landed on a comet, but it's not only the first one to land on a comet, it actually also was the first spacecraft to orbit a comet as well. Now, but before we talk about this amazing mission, let's stop and ask ourselves why scientists wanted to land on a comet in the first place. Well, they had two really big reasons as to why they wanted to go land on a comet. The first one being that comets are made of the same material from which our solar system was formed. So that means that they're really great for studying the ingredients that were present at the time when Earth and when life started. And the second reason is that researchers also think that comets might have just brought the same elements or the same ingredients to kickstart life, things like water or sugars that we need for life to exist. So we think that comets are a really good way for studying the start point of life and also the starting point of the formation of our solar system. Now, why did they choose this particular comet and not all the other ones that are out there? Well, there's two reasons. One, because it was pretty close to us. So, we have to be able to reach the comet within a few years. So this one was pretty close. So it was a good choice for us. And we wanted it to be a fresh, young comet. And what I mean by fresh is that it hasn't been contaminated or it hasn't been in contact with a bunch of other stuff. This particular comet has been in our solar system since 1959. So it's been here for a decent while. And we say that it's been in our solar system since 1959 because that's the first time that the gravity of Jupiter deflected the comet just enough so that it could get close enough to the sun to go around the sun and orbit the sun and be a comet. And so if you look in the top right-hand corner, I'm just going to move the video over here, you see this little circle pointing out this tiny, tiny dot. That's actually a whole entire spacecraft that's going around this comet. And here we have this little green dot, which is our comet, and the pink line being the trajectory or where our little spacecraft is going. Okay, so what scientists have to figure out before they could land a spacecraft on a comet? Because it's no easy task. Well, first they had to make a really detailed map of the surface of the comet because there could be things like big cliffs or craters that could damage the spacecraft. Because remember, comets, like asteroids, they're not smooth. They're really, really bumpy. Now, to make this comet, they actually used shadows because from the shadows, scientists could roughly figure out what the shape of the rock is. Kind of like how you as a human make a human-shaped shadow. So we can figure out from your shadow that a human probably made that shadow. So what you can do is you can program that into a computer, and then you can cover the whole comet and eventually map the comet using these shadows. Now the next step is to pick a landing site. Now this whole process from creating a map of the comet to actually finding the final place where you want to land your spacecraft takes 2 months. Now to give you an idea of the average time for you to plan this kind of mission for a trip to Mars, it actually takes scientists years to figure out where they want to land on Mars. But for landing on a comet, they actually only had 60 days, so they had to figure it out quite fast. Now, once they picked a landing site, they had to prepare the science instruments that Rosetta would carry to the comet. Now, the Rosetta spacecraft had everything, anything a scientist could want. It could sniff the gas there, it could look at the shape and material of dust particles, it could sample the surface of the comet. Basically, anything a scientist could dream of having, Rosetta had it. Now, once they had everything ready, they could complete the mission and send the Rosetta spacecraft to land on the comet. And once it arrived, it took tons of images and videos, just like this one that you see on the right-hand side here, where it looks like it's kind of snowing on the comet. Now, I remember when I first saw this video that you're seeing here, and I was blown away because I couldn't actually believe that we landed on a comet because it seemed like such a crazy, difficult thing to do. But humans are very talented and we're able to do crazy things like land on comets. Now, I just wanted to end with this picture again because I think it's really important. So in this picture, we're seeing a man-made object. This is the Rosetta spacecraft that you're seeing right here that's standing on a comet. And I think it's absolutely amazing that humans are able to achieve something like this by putting something that we made on a distant object in space that's traveling super fast around the sun, like this comet. And that brings us to the end. And so we're opening up for Q&A, and let's talk about asteroids and comets.
That's really cool, Rachel. So just so I understand, and maybe my friends can help me with this, if I think of a comet, I like your analogy of a snowball that's dirty. Or could you think of it like maybe my favorite, which is a chocolate chip cookie? So it's a cookie that has a bunch of chocolate chips inside, and maybe my mom put in some M&Ms into the chocolate chip cookie and the chocolate chips, and then maybe there's some Rice Krispies in there too. Would that be a good analogy for a comet?
For sure. It's basically just like a bunch of different things smushed together. So your chocolate chips could be like rocks, and your M&Ms could be like metal or anything else, and it's all just smushed together in this weird cosmic snowball.
But when I compare that with a meteor or a meteorite that lands on Earth, that's really only one thing. So maybe that's just a plain chocolate cookie.
Yes.
Nothing else in it.
Exactly. Now you're making me a little bit hungry, Trish.
I think we need some cookies this afternoon. Very cool.
Perhaps you answered it. What did they learn by landing on that comet?
So they went and when they basically sniffed the comet and took samples of the comet, they found what the kind of building blocks were for the formation of the solar system. So what we call elements, which I basically like to think of as the ingredients for making our solar system. So they went and found, kind of like what Trish was saying, like they found that it was made from chocolate chips. They found that there was M&Ms. And these are really what we call the elements from the beginning of our solar system. So it was really cool to almost be able to look back in time and see what the ingredients were when we formed our solar system just by sniffing this comet.
So maybe it was kind of like finding a chocolate chip cookie that wasn't from yesterday or a week ago, but maybe it was like a couple 100 years old chocolate chip cookie that you're investigating to see what they put inside.
Mm-hmm. Basically like finding a recipe for our solar system.
Very cool.
Adrian, what is your question, bud?
So his question is, a character from a show that he likes named Spacey said that there's lots of dust on the moon. And so he wants to know if moons have meteorites, or, I mean, what would you call them if they landed on the moon?
That's a really good question. So do you know what, Adrian, at the Space Center, we have a really cool meteorite. And that means it's a rock that's come from space and landed on the Earth. And it is actually a piece of the moon. So yes, there's lots of rocks and dust on the moon. And if something like this flies down and hits the moon, and a piece of the moon breaks off and floats up into space, and then that piece lands on the Earth, it's called a meteorite, and it can be a piece of the moon that comes back down to Earth. And we call it moon glass at the Space Center. And you can actually hold it up to the light and see through it. It's very green, almost looks like something Superman would have.
Taya and Mia are asking, are seeing meteors more common in certain areas of the world?
Yeah, that's a really good question. Maybe, I don't know, Rachel, if you know the scientific answer. I know seeing them, I'm not sure, but finding them certainly is. When you're looking for rocks that land back here on Earth, it's a really tricky thing to be able to find them. If you can imagine going to a field with lots of dirt and lots of hills and rocks and grass, it would be really tricky to find a rock that came from space versus a rock that just was there all along. So I know that oftentimes in the snowy Arctic and in the snowy Antarctic, you can actually find pieces of rock that have come from space and landed a lot easier. They stand out more. But Rachel, do you know the answer of whether there's certain places in the world that you can actually find them?
I'm not sure about certain places, but I know that there are certain times during the year where we expect more meteor showers.
She's right. There are certain times of the year when we can actually have better viewing for meteor showers. And we have that every August. And there's specific ones called the Perseid meteor showers that happen every August. And it's often when we're outside camping, which is great. And that's where we see shooting stars flying down towards the Earth, and we see them on a regular occurrence. In fact, you can put a lawn chair out, and even around 10 o'clock, 11 o'clock at night, you're going to see quite a few shooting down. So that's a really good time of year to look for them.
Parts of our orbit, as the Earth goes around our sun, are a little bit more cluttered than other parts. So we run into more stuff, so more stuff comes into our atmosphere, and more stuff makes it to our Earth's surface.
I don't know if any of our friends out there have seen shooting stars before. Have you ever been camping or been lucky enough to look up? They're very tricky to find. You know, they always say, can you wish upon a shooting star? But a shooting star happens so fast that you can't even think about a wish. You're just like, oh, a shooting, and then it's gone. They're very quick.
Our family, or my aunt rather, has a cabin at Green Lake, which is near 70 Mile House, close to 100 Mile House. And one of the things we really liked to do there growing up was laying out on the dock or on the lawn and watching for the shooting stars, because there's not the same amount of light out there. We would find satellites going through the air too, or not the air, rather the sky. We for sure have seen shooting stars, and it's pretty cool. And I personally, I don't know about other people, when they see shooting stars, even though I know it's coming, it still surprises me and feels so powerful.
Absolutely. And those satellites that you talk about are really cool to watch too, because if you're looking at them and you see them and you follow the track, if you wait, it's going to come back again to the same spot. And it's gone all the way around the Earth in that time, and it's pretty speedy.
That's really cool. Maybe that's something we can talk about another day too, is the objects that we see in our sky when we just lie down and take a look. So
absolutely.
All right, Natalia and Sasha.
How does it land on what we were talking about?
The comet?
Yeah.
That's a really good question, because what's really cool is that the Rosetta Spacecraft actually didn't have any rockets or boosters or any sort of way to change its direction. So when the scientists figured out they wanted to land on that comet, they had to be really, really careful that they were very accurate and precise, and that they had done all the calculations, made sure everything was perfect before they sent that spacecraft there, because once they sent it on that path or that trajectory, they couldn't change it afterwards. So it's really cool that they had to do a lot of math to get it to land on the comet.
That's really cool, Rachel.
Mm-hmm.
Sasha, do you have a question too, bud?
He said, is there any snow on the moon?
Oh, that's a good question. So there's not quite snow, but there is stuff that looks like snow. It's that kind of white, really fine white dust that you see on the surface of the moon. And it's actually, because it's so white, it reflects a lot of our sun's light. So that's what makes our moon look so bright during the night. But it's not quite snow, even though it looks like it is snow.
Cool.
One of my favorite missions is the research that's going on Mars, Rachel, where they didn't find snow, but they did find some ice at the polar ice caps, which was kind of cool.
That's cool. So Taya and Mia were saying earlier when we were talking about the meteors, they said that it says, my no-no said that he saw a meteor through the window one time.
Oh,
Oh,
yeah.
that's cool.
Yeah.
Very cool.
Now, James has a question. He wants to know, how big can a comet be?
Ooh, I'm not sure if there is a size limit on comets, but they are smaller than planets are. Some of them are pretty big. You can almost imagine them like big mountains going through space, big frozen mountains, but they are smaller than planets are.
And Rachel, don't most of the comets, as they get closer to the sun, start to melt? Isn't that always the case with the snowball?
They do, yeah. So that's why you get comet tails. So that little kind of trail that follows behind a comet, it's really because as they get close to the sun heats up the snow, heats up the ice, and it starts to melt or evaporate away. And that's the trail or the comet tail that you see.
So I'm old enough to remember a famous comet named Hale-Bopp. Do you know about that one, Rachel?
I do, yeah.
And
Did you?
that one had a tail on it, and it was circling around the sun. And I remember being a kid and going out and being able to see that. And it was pretty amazing because you're right, it did have a really large tail, and you could see it moving across the sky, and it was far away, but you could still see it really well. So that must have been a really big amount of snow and ice together.
Okay, so my name is Haley, obviously. And growing up, I would often have people say, Haley, like the comet. And I used to think that they were saying Haley, like the comic, but then I realized it was a comet. So can you tell me what people were talking about when they were saying Haley, like the comet?
Yeah, so they're talking about Halley's Comet that comes once every 70 to 75 years. I think it's 75 years that it comes around. And it's a particularly bright comet that you can see with your naked eye. So you don't need a telescope, you don't need binoculars or anything. You can see a really bright comet with its tail trailing by our Earth.
Cool.
And what's neat is that it's on a cycle, so it will come back around again. So
When was the last time that it was in orbit here that we could see?
Ooh, that's a good
in our lifetime? Already?
I believe 1986 was the last time, and it's going to come back in 2061 will be the
That
next
makes
time.
sense then, because that was the year after I was born. So it was something that was in people's minds. So pretty cool. So I guess technically I've probably seen Halley's Comet, but being a 1-year-old, you really don't see it. Or don't remember. But we'll ask Riley's question and then we will wrap up. Riley, what's up?
So, you know what? I don't really have a question, but I have something to tell you. It's really cool. It's about comets landing. So, let's pretend this piece of paper is the ground and this is a comet. Do you know why the comets go through the ground instead of just on the ground sometimes?
No.
Why's that?
Well, because people have been walking on it and it's weak, so it just goes through the ground. But do you know why sometimes they just stay on the ground and stay there?
No.
Well, that's because the comet, the ground is had no people walking on it, so the comet just stays there.
That's really cool.
And,
That's a really good analogy.
Yeah, that's an
Absolutely.
interesting hypothesis or theory or way to think about it. Maybe Trish, you can explain a bit too, because I'm wondering if it's not, it has something to do with how strong the ground is and how big the meteor is, right? So he's right in some way there. Hey, can you maybe elaborate on that a bit? I wonder, Rachel, if it has something to do with the speed at which the meteor is hitting the ground and the density of the meteor and the ground that it's hitting. Probably has something to do with it too. Does that make sense? Does that kind of sound like what you're thinking, Riley?
Yeah. So it's how big the meteor is and how fast it is and how weak or strong this floor is.
Riley, I wonder, you know what, one of the things that you could do between now and next week, maybe you can get your adults to help you research that a little bit more.
Yeah, totally, Riley. I would love to see what you can figure out with some help in the next week, and we can check back in with you next week. I will tell you that just last year, there were meteorites that landed in the province Saskatchewan, and the rocks were easily found. So I'm curious if your theory or your hypothesis is quite true. Perhaps the flat ground of Saskatchewan, maybe it was in a farmer's field that was not plowed or not dug up. So the rock actually stayed more on the surface than, say, if it had been in the mountains or the trees and landed that way. So I think that's a really good wonder, Riley. And I think we should all do a bit more investigation into that. And I can't wait to check back in next week.
So Rachel and Trish, do you guys have anything else that you want to add for today or to wrap us up here?
No, thanks for all of your wonders today, guys. You had some wonderful questions, everybody.
Awesome. Well, thank you very much, Rachel and Trish, for joining us today, and everyone else who came to listen and wonder. And if you have new wonders or new things that you're thinking about, you can find out more information on the Space Center website about lots of different things. Check it out and see if you can find answers to your wonders. So thank you very much, Trish and Rachel, for joining us.